Imagine having an elevator stretching from the Earth's surface into space to send things up and down. Sounds kind of wacky. For instance, what would stop it from falling back to Earth? You have a ribbon in this case, or a cable, one end attached to an anchor point on Earth, the other end 62,000 miles up in space. And due to the rotation of the Earth, the upper end is thrown outward. The lower end is pulled down by gravity and it remains stationary, sort of like spinning a ball on a string around your head. Dr. Bradley Edwards from the Institute for Scientific Research isn't the first to think of the idea for a space elevator. Physicists have been toying with the concept for years. Edwards believes a space elevator offers a cheaper, safer form of space travel that eventually could be used to carry explorers to the planets. Edwards' elevator would climb on a ribbon made of nanotubes, tiny bundles of carbon atoms many times stronger than steel. The cable would be attached to a platform on the equator. The cable would be about 3 feet wide and thinner than a piece of paper, but capable of supporting a payload of up to 13 tons. At this stage, they don't have the capability to fabricate the carbon nanotube cable. The whole thing is a visionary proposal that has lots of interesting features, but it's no more than that. The renowned science fiction writer Arthur C. Clarke popularized this idea in the 1970s, but Edwards says now the idea can become reality. He probably needs about 2 more years of development on the carbon nanotubes to obtain the strength needed. After that, work on the project can begin. Edwards envisions launching sections of cable into space on rockets. A climber, his version of an elevator car, would then be attached to the cable and used to add more lengths of cable until eventually it stretches down to the Earth. Then, going into space would simply be a matter of pressing the up button. These are images of huge plasma clouds of hot gas that are emitted from the Sun. When these clouds get near Earth, they can cause major disruption to radio communication systems and in extreme cases can cause the total loss of satellites. The research team at Birmingham University has built a monitoring system that provides early detection and monitoring of the gases. Their imager will be used by the United States military on Coriolis, a space mission launched earlier this year to discover more about these huge plasma clouds. SMEI is capable of capturing an image of the entire sky every 1.5 hours, enabling scientists to keep a careful watch on all activity around the globe. The system will be able to provide a warning of up to 3 days before the actual arrival of any mass gases, coronal mass ejections or CMEs to Earth. The prototype of the air-breathing engine that would allow air travel at more than 8 times the speed of sound was lifted into the upper atmosphere on a rocket and allowed to plunge back to Earth. Scramjets use the rush of oxygen in the air to ignite hydrogen fuel. They could cut flight times from Sydney to London to just 2 hours from 24 hours now and could slash satellite launch costs by freeing up more space for payload. The groundbreaking experiment came after a failed test of US Space Agency NASA's multi-million-dollar unmanned X-43A scramjet prototype and a previous attempt by the high-shot crew that went awry when their rocket spun out of control. Data from the high-shot scramjet, short for supersonic combustion ramjet, was fired off in a capsule after the engine was due to ignite at 35 kilometers above the ground while traveling at around 7.6 times the speed of sound, 8,000 kilometers per hour or more. The scramjet then rammed into the ground, destroying it and completing the test. A Royal Australian Air Force spokesman said he was confident the test was successful this time round. This was the first time a scramjet was ever run, and therefore it was the first in the world. Project engineers from the University of Queensland team leading the project expected to have all the data in hand and would then know whether the engine had worked as planned. High-Shot Flight Program Director Dr. Alan Paul explained how it was world first and very significant that Australia had played a large part in this experiment that may develop to become a game, a business, or even an industry. It's a fairy tale wedding made in heaven, where love has triumphed over bureaucrats saying no. Russian cosmonaut Yuri Malenchenko, the commander on board the International Space Station 240 miles above Earth, married Russian immigrant and Texan belle Ekaterina Dmitriev. They tied the knot via an Earth-to-space telephone and satellite link to make space history. All of this against the wishes of Russian authorities, who had previously strongly discouraged their cosmonaut from going ahead with the wedding. The officials had cited security concerns. Malenchenko is a military officer and subject to strict regulations on marrying a foreigner, as well as the fact that the procedures for a space wedding had never been written up in the cosmonaut Code of Conduct. The spokesman for the Russian Space Agency said that officials may have been powerless to keep their love-stricken ISS commander from going through with his wedding, but they can make sure it never happens again. And yet, while Russian officials may not approve of the wedding, they also appear to be somewhat proud of once again creating another space first. So it's from Russia with love, just as long as they don't try this ever again. Amid the landscaped beauty and campus-like setting of the Johnson Space Center, the business of manned spaceflight is played out in a variety of specialized facilities. Open access to most of these areas affords visitors and employees alike the opportunity to witness firsthand the inner workings of the manned space program. But some areas, because of hazards or reasons of access, remain out of the eye of all but a select few. One of them is at NASA's Weightless Environment Training Facility, or WETEF. Here, it's no problem to see where the action takes place, but few people ever get the chance to submerge themselves into the watery test area for a closer look at what goes on. In the neutral buoyancy of this huge water tank, astronauts hone their ability to work in the cumbersome spacesuit, providing vital input for hardware development and perfecting critical timelines for PVA tests. This is all done in the closest thing to long-duration microgravity that can be found on Earth. It's been over 3 decades since humans set foot on the surface of the Moon. Since the last Apollo space mission in 1972, technology has improved by leaps and bounds. Now, with the incredible advances in technology since that historic era in space travel, private enterprises are now looking to the Moon as the next frontier for commercial development. Could it ever be possible to replenish the Earth's supplies of gemstones and little-known rare metals such as osmium and rhodium by sending humans or even robots into space to set up mining ventures on the inhospitable surface of the Moon? An increasing number of private firms see no reason to wait for the world's governments to take the lead and are racing to launch their own space mining missions. ASI is helping sponsor a project to build a commercial manned moon base and plans its first lunar flight in the next 10 years. According to them, technology is not the problem, rather just how to raise the massive amounts of cash required. Once built, one of the more profitable uses of the lunar base will be for adventure tourism. Under the Artemis model, a tourist would pay about $250,000 for the adventure. Obviously, the first few tourists would be living in very Spartan conditions, but it would be a chance for somebody to walk where nobody has ever walked before, pick up your own moon rock and bring it back, even hit a golf ball a mile if you feel like. The United Nations 1979 Moon Treaty, one of several international outer space agreements, attempted to define the scope of private space activity. However, it was never ratified by some major powers such as Russia and the United States. The treaty stipulated that any wealth obtained from the moon by any spacefaring nation was to be distributed to all the people of the world. One clause referring to space resources as the common heritage of mankind has been taken by private firms as legitimizing efforts to mine on the moon and asteroids. There are enough rare minerals on the moon to make a commercial venture pay off. The largest obstacle is the lack of water used in large quantities in most Earth mining operations, but only believed to exist as ice at the lunar poles. Similarly, there is a lack of oxygen, which does exist on the moon, but is bound up in compounds that are hard to break down. The low gravity situation means that robotic mining would probably be more sustainable than sending humans into space. Apart from serious practical problems, the first obstacle for companies looking to mine on the moon is cost and return on investments. Experts say the cost of transporting items into space is exorbitant, and meaning that any lunar bases would really have to be able to procure their necessities from space. The American rocket pioneer Robert Goddard. He was called the Moon Man and laughed at for being an inventor and a dreamer. However, he continued to design, invent, and test. His neighbours complained when he used his Aunt Effie's farm in Albury as his first proving grounds for his rockets. He moved to New Mexico later with a grant from Daniel Guggenheim and was accompanied by his camerawoman and wife, Esther. In 1926, Goddard had invented and launched the world's first liquid-propelled rocket. Goddard had also patented over 200 elements of rocketry, from multi-stage rockets and fuel pumps to clustered engines. 4 years later, in 1930, his rockets were achieving speeds of 500 miles per hour and altitudes of 2,000 feet. The 3 Apollo astronauts were born this year. Goddard envisaged an age of space, but it came too slowly, and he died before witnessing it. Man's progress into space has a lot to thank Robert Goddard for. Scientists say the Big Bang that began everything 15 billion years ago produced particles of matter and antimatter that immediately cancelled each other out to produce radiation. But where did the universe and all that is in it come from? Physicists have a theory that more particles of matter were produced than antimatter. Mike Pendlebury of Sussex University is trying to find proof for this theory. Pendlebury and his team are building a machine linked to the idea that the most promising fields or types of measurement that may form another link on the theory of the shapes of the fundamental particles out of which atoms and molecules are built. Mike and his team are collaborating with a university in Japan to build a machine able to detect minute differences in the spherical shape of neutrons. To find better statistics on the measurements so that smaller effects can be seen, they're planning to obtain more particles, in this case neutrons, on which to make tests. A group at the University of California at Berkeley have been working on this for 20 years or so. They have reached the limits of what they can do using their technique, so this new molecule and the new system they've discovered is really the way to make progress on these kind of measurements. What looks like a scene from a science fiction movie is actually real. Scientists from NASA's Jet Propulsion Laboratory have digitally manipulated spacecraft data from Venus to give us a bird's eye view of its surface. The scientists have taken the idea of being there a few steps further. By strapping on 3D visual display goggles and specially censored gloves, one can be immersed into new worlds. What is unique about virtual reality is that the user has complete control over the environment. Head or body movements translate directly into the way a simulated Martian landscape is seen. In another example, the task is to withdraw a square shape from its slot. The operator's gloves can be manipulated to control the robotic arm, whilst sound cues help with depth perception and finding proper fit. Scientists have also designed a virtual wind tunnel. The investigator can move anywhere in the tunnel to study airflow. Virtual reality gives the operator complete choice and is used for a variety of commercial applications. Virtual reality is an idea that dates back to the 60s and is quickly becoming commonplace. It was used during the Gulf War to train tank commanders and soldiers. The American bobsled team honed their skills for the Olympics with a form of virtual reality. And the Japanese have developed a system that allows architects to walk clients through a virtual building before it's constructed. The dry valleys of Antarctica may soon become a far-reaching outlet for this technology. Scientists have long been interested in the area because it's so similar to Mars. Its frozen lakes contain primitive microbial gnats that live in the water below many feet of ice. Researchers use a form of virtual reality called telepresence to operate a remote imaging and sampling vehicle to explore this bizarre world. The potential of virtual reality and telepresence in planetary exploration is very promising. If we were to travel away from the sun, leaving the planets behind till they fade into the blackness of space, and until the sun itself is just another bright spot in the sky, we would see a thin cloud of objects enveloping the entire solar system. These are the primordial comets, billions of icy globes no more than 30 miles across. They have been here unchanged since the beginning of the solar system. Halley's Comet began its first journey around the Sun thousands of years ago. When it came close to Earth in 1986, NASA and the Jet Propulsion Laboratory developed a mission to intercept it with a spacecraft. It was an opportunity too good to be missed to investigate the best-known comet of all at close range. The craft used hardware and technology from the successful Voyager mission to Jupiter and Saturn, and from the Galileo mission to orbit Jupiter. It was equipped to examine the comet in detail and carried an electronic camera to produce highly detailed pictures. Other instruments, many from Voyager, were added to reveal the comet's chemistry, record its ultraviolet and infrared radiation, measure its magnetic field, and collect samples of its dust. This unique mission began in the summer of 1985, and NASA's space shuttle was used to launch the probe on its 8-month journey to Halley. Guiding the spacecraft to a successful encounter required the pinpoint techniques learned from over 20 years of space exploration.